Arduino calculator. A calculator is a machine that allows people to do math operations more easily. In this tutorial, we will build our own calculator using Arduino. The values can be entered through a 4x4 keypad, and result can be viewed on a LCD screen. This calculator could perform simple operations like addition, subtraction, multiplication, and division with whole numbers. Here is the connection diagram of this project. 16x2 LCD display has two lines. Each line can display 16 characters. This display has 16 pins. First pin is ground, second is VCC, then contrast, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, VCC, and ground. Pin 1 and 2 provide the supply for its internal circuitry, and pin 15 and 16 provides the supply for its backlight. We have connected pin number 1, 5, and 16 with the ground pin of Arduino, and pin number 2 and 15 with the 5V. Pin number 4 of LCD is connected to the pin number 12, and pin number 6 of LCD is connected to the pin number 11 of Arduino. Pin 7, 8, 9, and 10 are not used. Pin 11, 12, 13, and 14 of LCD display are connected to the pin 5, 4, 3 and 2 of Arduino respectively. A 16-button keypad has 4 rows and 4 columns. It has 8 output pins. 4 pins are connected with the rows, and 4 pins are connected with the columns. Pressing a button will short one of the row output to one of the column output. From this information, the Arduino can determine which button was pressed. For example, when key 3 is pressed, column 3 and row 1 are shorted. Arduino detects it and inputs 3 to the program. We have connected row 1 of keypad with a 0 pin of Arduino, row 2 of keypad with a 1 pin of Arduino, row 3 of keypad with a 2 pin of Arduino, row 4 of keypad with a 3 pin of Arduino. We have connected column 1 of keypad with a 4 pin of Arduino, column 2 of keypad with a 5 pin of Arduino, column 3 of keypad with pin 0 of Arduino, column 4 of keypad with pin number 1 of Arduino. This is the code of our project. To control the LCD display, we will first include its library in the program. To include the library, we will write in the first line #include liquid crystal.h. Now we will declare the name of the used pins in the sequence of RS, enable, D4, D5, D6, and D7. We have connected RS pin of LCD with pin number 12 of Arduino, D7 of LCD with pin number 2 of Arduino. Now we will include the library of the keypad. To include the library, we will write #include keypad.h. Now we have declared 2 variables. One is rows, and second one is columns. We have given value 4 to both the variables, because we are using 4x4 keypad. Now we have declared a 4x4 2D array, keys, and give the name to each array location. Now we have declared 2 arrays, row pins, and column pins. Each array has 4 locations. In this array, we have declared that which pin of Arduino is connected with the row pin of keypad, and which pin of Arduino is connected with the column pin of keypad. This line will take the values of variables from the previously defined values. num1, num2, and number are 3 long type variables. Key and action are 2 character type variables. Void setup is a function in which we have initialized the LCD. LCD.begin 16,2. It means we are using 16 columns and 2 rows of the LCD display. Void loop. This function will run over and over again, so whatever we write inside, it will repeat forever. Key equal kpd.getKey. This function will scan the keypad. If any key is pressed, then variable key will store the name of that key. LCD.print will display the name of that key on the LCD screen. If key pressed equal no key, this function will execute the code written inside the brackets till any key is pressed. If pressed key is asterisk, then Arduino will clear the LCD screen and give value 0 to all the variables. Now when we enter the first digit of the number, then Arduino store it in a variable number. Now when we enter the second digit, then Arduino will multiply the first digit with 10 and add the second digit in it. After entering the first number, we will enter the action like plus, minus, multiply, or divide. When we enter the action, then Arduino will store the first number in the variable num1 and store the action in a variable action. Now we will enter the second number, then we will press the equal button. When we press the equal button, then Arduino will store the second number in the variable num2. After pressing the equal button, Arduino will start the calculation according to the operation stored in the variable action. If operation is plus, then Arduino will add the two numbers. If operation is minus, then Arduino will subtract the two numbers. After that, Arduino will store the final result in the variable number. LCD.print number. It will print the final result on the LCD screen. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Now we will assemble our hardware. We will take 3 wires, 1 red and 2 black. We will use these wires later. Now we will solder a black wire at hole number 1 and red wire at hole number 2 of LCD display. Now we will solder a white wire at hole number 4 and brown wire at hole number 6 of LCD display. Now we will solder orange, yellow, green, and blue wires at pin number 11, 12, 13, and 14 of LCD display. Now connect hole number 16 with hole number 1 using a black wire, and hole number 15 with hole number 2 of LCD display using a red wire. Now connect hole number 5 with hole number 1 of LCD display using a black wire. Now connect hole number 3 with hole number 1 of LCD display through a 1 kilo ohm resistor. Connect the red wire with 5 volt pin and black wire with the ground pin. Now connect white, brown, orange, yellow, green, and blue wires with pin number 12, 11, 5, 4, 3, and 2 of Arduino respectively. Connect the gray wire of keypad with pin A0 of Arduino, purple wire with pin A1, blue wire with pin A2, green wire with pin A3, yellow wire with pin A4, orange wire with pin A5, red wire with pin 0, and brown wire of keypad with pin number 1 of Arduino. Now we will power up our circuit and test its functionality. We will first enter the 2 whole numbers and add them. Now we will subtract the 2 whole numbers. Now we will multiply the 2 whole numbers. Now we will divide the two whole numbers. We can see that our calculator is giving the correct result. I hope you enjoyed the video and learned something from it. For any help in your project, or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.